So in this example, we're given a system of interconnected resistors, and we're being asked if we could replace all these resistors with just a single resistor. So we're looking in from these two terminals here, looking in this direction at what's the equivalent resistance. So there should be one resistor that we could find to replace all of these. That would be our equivalent resistance. So this is going to require us to do some combinations of resistors in parallel and in series. So we want to recall over here, just as a reminder, when we have resistors in parallel, which we indicated by that, then it's going to be the first resistor value times the second resistor value divided by the first resistor value plus the second resistor value. And then, of course, when we have resistors in series, we simply just add them. So that's R1 plus R2. Okay, so now let's start looking at our network here that we have. And so the first thing we notice is we have these two resistors here, and they are in parallel. So we should be able to replace those two resistors with just one resistor. So to do that, we need to calculate that. So it'll be, we'll call it R36, since it's a 3 ohm and a 6 ohm resistor. And so in this case, it'll be 3 times 6 over 3 plus 6. So when we multiply that out, that's going to be 18, and then 9 on the bottom. So this is a 2 ohm resistor right here. So we can replace those two resistors with just one resistor, which is going to be just 2 ohms. So to do that, we can take off one of these legs here. We don't need it anymore. So we'll do that. And then this value can go to 2 ohms. So now we have 2 ohms. Okay, so we've reduced our network some already. Now we see another easy way to reduce this, and that is we have this resistor and this resistor in series, excuse me. So that's easy enough. We said that we'll call this 1, 2. Then when they're in series, we just add them. So in this case, it'll just be 3 ohms. So now we can replace those two resistors with just one 3 ohm resistor. So let's do that. So we can get rid of this resistor altogether. And then this guy is going to be a 3 ohm resistor. And then we'll make that connection where that resistor used to be. Okay, so now let's look at what we have. We've reduced it by a little more. Next step we can take is we notice that this resistor and this resistor are in parallel. So again, we can make that calculation, and we'll call this R33, and that's going to be 3 times 3 over 3 plus 3, and so that's going to be 9 over 6, so we'll call that 1.5 ohms. So those two resistors can be replaced by one resistor that is 1.5 ohms. So to do that, we can just get rid of this guy altogether now. We don't need him anymore. And then the value of this one will change to 1.5 ohms. Okay, so we're getting close. We have a little bit more work to do. So the next thing we notice as we look at our diagram here is that we have this resistor and this resistor in parallel. So we need to find an equivalent resistance that we can put in its place. So it's just two resistors in parallel. We know how to do that, so we will call this one R11 since they're two 1 ohm resistors. And so that'll be 1 times 1 over 1 plus 1. And that's going to be 1 over 2. So we'll just call that a 0.5 ohm. So So those two resistors can be replaced with just a 1/2 ohm resistor. So we will do that. So now we won't even need this guy here at all. So we'll eliminate that one. And then the value on this one can just be 0.5 ohms. So far, looking in from this, our equivalent, we should have not seen any changes to what we measure there if we put an ohm meter there. Okay, so now we look at our circuit again, and we see this resistor and this resistor are in series. So again, we can easily correct that. So that's our 0.5 in series with 1.5, and so we'll say that's just 0.5 plus 1.5, and that's equal to 2 ohms. So now we can replace that guy with one resistor of 2 ohms. So we'll go ahead and do that. So this one can go away entirely, and then this one value will change. So this is now a 2 ohm resistor. And so finally we have two resistors that are in parallel. So we can easily reduce that. So it's a 2 and a 2. So that's going to be 2 times 2 over 2 plus 2. And that's going to be 4 over 4. And that's going to give us 1 ohm. So now the final step is that we can eliminate this one altogether, and we're left with just 1 ohm. So that entire system of resistors could be replaced by one 1 ohm resistor. So that is our equivalent resistance looking in from those terminals.